One of the really powerful things about Bayes' theorem is that it allows for updating our probabilities based on new data. So let's suppose that we have a fourth marble, and it is also white. Okay? How would we update our probabilities? Well, we would set up the same type of Bayes' theorem formula that we did before, but these values, probability of A1, probability of A2, they become our new prior probabilities. They become our new priors for short. Okay? So we have the same Bayes' theorem formula, but instead of using 1/2 and 1/2 by the principle of indifference, we now can use 8/9 and 1/9. So let me show you what I mean. The probability that we have urn 1 given 3 whites and a fourth would be equal to probability that we would observe a white marble from urn 1, which would be probability that we would observe a white from urn 1 times the prior probability that that is the urn that we're observing, okay, divided by the total probability of the data, which would be the probability that we are observing white given that it's urn 1 times 8/9, plus the probability of observing white given that it's urn 2 times 1/9. Okay. So this on the top is going to be equal to 0.2 times 8/9. And on the bottom we have 0.2 times 8/9 plus 0.1 times 1/9. But if we convert them to percentages, the probability of urn 1 is 94.12% now, and probability of urn 2 is 5.88%. So this probability is down. It was previously 11.1%, and this probability is up. It was previously 88.9%. The different parts of the Bayes equation have special names. Okay? Here I've written the theta to indicate the different parameters that were possible. In this problem, urn 1 had a parameter of 0.2 probability white, and urn 2 had a parameter of probability 0.1 of white. Okay? But you can use A's if that seems more familiar and comfortable. Okay? The result is the posterior probability. Posterior means after, so this is after new data are observed. It's our best estimate of the probability of which parameter is active, the 0.2 parameter or the 0.1 parameter, after new data. The prior probability is what we started with either before any data were observed or before new data were observed. Before any data, we would have 0.5. Before new data, we would have 8/9 and 1/9. Okay? The standard forward probability part of the problem, the probability of the data given each parameter sub I, is known as the likelihood. Okay? And the probability of the data on the bottom is the marginal probability, which, as we know, is equal to that term on the top for the first, and that term on the top for the second, and so on for however many terms there are.